3.3 Graphical method of solutions of a pair of linear equations. Right. So in this concept, we are now doing the second example. So Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for ₹18. So represent the situation algebraically and graphically. So first step we have to do is we have to see what is the information that is provided in the given question. So here we can clearly see that there are 2 conditions that are provided in the question. The first condition is Romila purchased 2 pencils and 3 erasers for ₹9, and the second condition is her friend also bought 4 pencils and 6 erasers of the same kind for ₹18. So now by using these 2 conditions, we want to frame 2 equations. After framing 2 equations, we want to find what are the coordinates of x and y values corresponding to the given 2 equations, and then we have to plot the graph, and we want to see what is the shape of the graph. Right? Okay. Now I am framing these 2 equations by using these 2 conditions. Before that, let us consider the cost of 1 pencil be x and the cost of 1 eraser be y. The cost of 1 pencil be x and the cost of 1 eraser be y. Now, by using the first condition, they have given 2 pencils plus 3 erasers she brought for ₹9. So that is 2 into the cost of pencil, that is considered as x, plus 3 erasers, that is 3 into cost of each eraser, we consider it as y. So 2x plus 3y, that is 2 pencils into 3 erasers. So she brought for ₹9. So this is considered as equation 1. And now by using second condition, we have to frame second equation. So 4 pencils and 6 erasers, so she purchased it for ₹18. So 4 pencils, that is 4 into cost of each pencil, that is x, plus 6 erasers, that is 6 into cost of each eraser, that is y, which is equal to 18. So these are the 2 equations we are framed by using the given information. Now we want to solve these 2 equations and we want to find what is the coordinates of x and y, and now we want to plot the graph. Okay. So after plotting the graph for 2 equations, we can observe 2 lines. Why? Because these 2 are representing the line equations. So while plotting a graph, we can clearly see that there are 2 line equations in a single graph. But here, while we observe the graph, we can see only 1 line equation, so which resembles both the equations. Do you find that difference? Here, for 2 line equations, if you represent in a single graph, we can obtain 2 lines. Either they may be parallel or they may be intersect at any point. But here, when we plot the 2 line equations in a single graph, we can clearly observe that these 2 lines, there was no 2 lines representing in the graph. There was only 1 line that is representing both line equations in the graph. That is, this equation is geometrically represented by a pair of coincident lines. That is, the solution of the equation are given by the common points. So, are there any common points on this line? Yes, from the graph, we can clearly observe that every point on the line is a common solution to both the equations. So, this is the cause. So, we are seeing only 1 line equation. Why? Because 1 line equation is passing through the other line in the same direction, in the same points. So that we are seeing only 1 line equation, but it contains 2 lines. Okay. So the equations 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18 have infinitely many solutions. So each and every point is common for both the lines. So this should not be surprise us, because if we divide the equation 4x plus 6y is equal to 18 by 2, then we are getting 2x plus 3y is equal to 9, which is same as equation 1. So that is both the equations are equivalent. So from the graph, we can see that any point on the lines gives us possible cost of each pencil and eraser. So for instance, each pencil and eraser can cost 3 and 1 rupee, or each pencil and eraser cost 3.75 and 0.50 and so on. So for this type of coincident lines, we cannot say it has an finite solutions. Why? Because each and every point is common for both the line equations. So we say there are infinitely many solutions. So we cannot treat the cost of pencil and eraser as a single. Why? Because it has infinite number of possibilities in which these two conditions are said to be valid. Okay.